Hey guys, this is Mr. Chun. I'm just going to finish off what we had started talking about in class, okay, and just do a quick review of what we've done so far. Okay, so we talked about special triangles and how you needed to know these different triangles. Just remember that this is really a box, and from the square box we can create this special triangle of 45, 45, and 90 degrees. This is actually an equilateral triangle. That is another 30, and that's a 60. Okay, so that's kind of a nice way to remember this. You can think of this as a triangle. This starts out as a box and becomes a triangle. Okay, and this one we cut in half. So you do need to know the values of these, the angles and the sides of these triangles, because they're really important for later on. Okay, we talked about in class, we talked about the special values, what the ratios of certain angles, the trig ratios of certain angles were. Specifically, we talked about pi over 4, pi over 6, and pi over 3, pi over 4 being 45 degrees, pi over 6 being 30 degrees, and pi over 3 being 60 degrees. Okay, so make sure that you are familiar with this for this unit. Okay, we also talked about this special table that you can use to remember the trig ratios. In particular, we talked about these three values. Okay, and you can notice that there's a pattern here when you look at the numbers. Okay, we talked about this being 1, 2, and 3. If you order this from smallest to greatest, for the sine value, you have 1, 2, 3. For the cosine, you have 3, 2, 1. Okay, so what you can do if you want to use this for the test is you can write 1, 2, and 3 here, then take the square root, then divide by 2. Okay, and that's the same thing for the cosine ratios. You can start with 3, 2, 1, and then take the square root of each of those, and then divide by 2. The square root of 1 is just 1, and that's why you end up with 1/2 here. Okay, so that's kind of a shortcut way of remembering the trig ratios, but you do need to understand that they come from the triangles. Okay. And of course, relating these to the unit circle is important as well. Remember that the tangent is just the sine over cosine. Okay, so this over this is 1, this over this is root 3, 1 over root 3 is root 3 over 3. Okay? And this turns out to actually be 1 over 0, which is 0, or sorry, undefined. So it becomes, we can express it as an infinity symbol because it's going on forever and ever. Alright, this is actually a filled out unit circle that I would like you to remember. You do need to memorize this or be able to figure it out quickly, okay, whichever one is more convenient for you. If you understand what's happening, it's a lot more effective, and it's going to make your life easier. Okay, so you should have received a worksheet from me. I know Jennifer left early, so if you didn't get the worksheet, you can draw this in your book, in your notebook, and try to practice being able to write the coordinates, the x, y values for each point here, for each of the points. Remember that this point here, this pi over 6 represents that angle, and same with that and that. These values represent the degrees, and these represent the the angle measure in radians. Remember that this is the cosine value, which is the same as the x value. The second one is the sine value of the given angle, and that is the same as the y value. Sorry, that's kind of messy. Same as the y value. Okay? And you should be able to do this for all the angles in the 4 quadrants, okay, for the special multiples. So notice that these are all multiples of pi over 6 or pi over 4. Pi over 3 is really just 2 pi over 6, right? 2 pi over 6, and that becomes pi over 3. Okay, so you should be able to keep, just counting multiples of pi over 6 or pi over 4. So for instance, if I said, what is, let's see, 4 pi over 3, okay, you could just do this, if you had a chart, you could look at it, but if you're not really sure, just remember that it's the bigger angle, or that's really the same as multiply top and bottom by 2, so that would be 8 pi over 6. So you could go 1, 2, 3, 4, 5, 6, 7, 8, and then you would reach an angle going from here to here of 4 pi over 3. Okay, so being able to find the points on the unit circle that correspond to a given angle is important, and then you should be able to find the cosine and the sine value based off of that. Remember that these are just simply triangles. You can create triangles by first going in the x direction, minus 1/2, and then moving in the y direction, and in this case it's minus root 3 over 2. Okay? So now you have an x value and a y value, and you know that this radius is always going to be 1, so you can figure out the trig the trig ratios for this given triangle using these values. Okay? We will have a quiz on this when we get back on Friday, the week of SEW. Okay? Alright, so let's try a couple examples. This is example 14 and 15 from your textbook. It says, find the exact value of sine alpha, cosine alpha, and the tangent of alpha, given that the alpha, or the angle, is 3 pi over 4. Okay, so how would I do this? Well, the easiest way is to use your unit circle. Okay, so I've got to somehow represent this on my unit circle, and then I'll be able to find my sine, cosine, and tangent values. And I should be able to know that this is a multiple of pi over 4, isn't it? So I'm going to go ahead and draw my circle. Pi over 4, 3 pi over 4 means that I have 1, that's 1 pi over 4, right? 2 pi over 4, and 3 pi over 4. So that means it's going to be in the second quadrant. Okay, it's going to be over here, and that angle is going to be 3 pi over 4. Okay, so now I'm asked to find really what's my sine and what's my cosine here. That's kind of like my x value, that's kind of like my y value. So it's saying what is x and what is y right here. Okay, so I need to figure out the coordinates of that point, and then I'll be able to figure out the x and the y value, right, that correspond to that point. Okay, so if this angle here is 3 pi over 4, okay, then you should remember that this is a special triangle, a special case of 45, 45. So that's 45, that's 45. So if this is 1, that's going to be 1 over root 2, and that's 1 over root 2, right? This is when it's in the first quadrant. But because it's in the second quadrant, we can say, well, because we're going in this direction, it's going to be negative, and that value is going to be positive. So x is going to be negative 1 over root 2, and y is going to be positive 1 over root 2. Okay, and x is just the cosine, so that's the same as the cosine of alpha, and that the y is the same as the sine, so we're going to say the sine of alpha. Okay, so those are two answers that I've just found. And then the tangent, of course, is the quotient of sine of alpha over the cosine of alpha, right? And that's equal to the tangent of alpha. And so that becomes negative 1. Okay? All right, so that would be my tangent of alpha, And you could actually write tangent of 3 pi over 4 to be more precise. Okay. All right. Let's try another one. Find the exact values of sine of 4 pi over 3, cosine of 4 pi over 3, and tangent of 4 pi over 3. So again, we're going to notice here that this angle here, 4 pi over 3, is a special angle. It's a multiple of pi over 3, and pi over 3 is really the same as 60 degrees, right? So we're going to find 4, we're going to add 4 60 degrees, okay? So 60 degrees was kind of the bigger angle. It was up here, right? So 60, that's 1. We're going to add another 60, that's 2. If we add 3 60s, we get 180, so actually we end up with pi, okay? And then we're going to add 1 more, so that's 3, okay? If I draw it here, that's 1, that's 2, that's 3. That's 3 pi over 3, right, which is the same as pi. And then I'm going to add 1 more. So that's going to be, that total angle now is there, then 4 pi over 3. Okay? So now that I found 4 pi over 3, I just need to find, we're going to assume this is 1, and I just need to find what my x value is, what my y value is. Well, if you remember that this is going to be 1, and this is 1/2, because that's 60, right? And that's 30. And so we have 1/1/2 and root 3 over 2. Ooh, my stylus isn't very good here. Okay, so that's root 3 over 2. Then you know that this is going to be negative root 3 over 2, because it's kind of like flipping it. We're going to flip it this way, and then we're going to flip it this way. So that's how we get that. So this is going to be negative 1/2 and negative root 3 over 2, and that works out nicely. Okay, so you can write the sine of 4 pi over 3 then is going to be the y value, which is negative root 3 over 2, and the cosine of 4 pi over 3 is equal to negative 1 over 2. Okay, so and then the tangent, of course, is the division of those two. We're going to do sine over cosine, so that becomes root 3 over 1, which is just root 3, and that's positive, okay, because I'm taking this value divided by this value, okay? So fairly simple. Eventually you want to be pretty quick and get enough practice so that you can do this pretty quickly, okay? All right, let's try a couple more. We have we have this problem that says without using a calculator, show that 8 sine of pi thirds times cosine 5 pi over 6 is negative 6. Okay, so this looks a little bit more complicated, but let's use a problem-solving strategy here. If I see a big, ugly, complex problem, a way that I can solve this is by breaking it down into smaller problems. Okay, so let's break this down into smaller problems. Let's see, is there anything that we recognize here? Okay, you should recognize here that this looks sort of familiar. Okay, we know a sine, and that looks pretty familiar. The cosine of 5 pi over 6, that looks familiar from my unit circle. Okay, so maybe I can replace this. If I know this number, and I know this number, then maybe I can substitute those values in, and then show that this side is going to be equal to negative 6, okay? Because that's what they're saying, right? They're saying show that one side is equal to the other, so I really have to work with one side, okay? So if I can just leave this side alone, if I can leave this side alone and just work with this side, then I'm showing that this is true, okay? So let's use our unit circle here. Let's figure out what sine of pi over 3 is. Okay, and then figure out what cosine of 5 pi over 6 is. Okay, so let's draw the unit circle again. What's pi over 3? We said that's 60 degrees. So we have, this is 1, that's going to be 1/2, and that's going to be root 3 over 2. Okay, and those are all positive numbers, right? Because that point right there is in the first quadrant. So the sine is the y value here. So the y value there is obviously root 3 over 2. And let's go ahead and try and draw the cosine of 5 pi over 6. 5 pi over 6 on the unit circle will be, okay, remember that this is a fraction, so 6 pi over 6 is over here, isn't it? Okay, 6 pi over 6 is really just the same as pi. Okay, so that means it's pi over 6 less than pi, so it's probably going to be right here. Okay, so that's going to be my triangle. My x value is going to be here, and my y value is going to be here. That's the point that I'm interested in, okay, because that is 5 pi over 6. Okay, so for 5 pi over 6, that's a 30, 30, 30, 60, 90 triangle, where now this is 1. That turns out to be negative root 3 over 2. Okay, so that means the x value then is negative root 3 over 2, which becomes, which turns out to be the cosine of 5 pi over 6. So negative root 3 over 2. Alright, so now let's go back to the problem, and it says, now that we've found these simpler numbers for these expressions, let's plug these back into, plug these back into here. Okay, so we have 8 times root 3 over 2 times negative root 3 over 2. And we've got to somehow show that this is negative 6. So we're just going to work with this without this. Okay, we're just going to work on this expression. So this becomes, well, those cancel out. That becomes 2. And root 3 times negative root 3 is just negative 3. So we have 2 times negative 3, and so that becomes negative 6. Okay, so we've shown that this side is indeed negative 6. All right. Okay, now the next example says find all the angles between 0 and 2 pi. Okay, so theta has to be a value between 0 and 2 pi, and the cosine has to be 1/2. Okay, so we've done this kind of problem before, I think. Where are the angles where the x value is going to be 1/2? Well, we've done this. Okay, this would be 1, 1. We're really looking at what angle is that going to be, and what angle is that going to be. Okay, so I need to find that angle, and I need to find that angle. Well, the cosine is 1/2, so that means that's 1/2. So this is a special triangle right away. You can see that. That's going to be root 3 over 2. Ooh, root 3 over 2. Sorry, that's kind of hard to see. Okay, so this is, the first angle is going to be 60, which in radian form would be, so theta is pi over 3. And now we have to still find the other angle. Okay, and the other angle is really, it's the same triangle. So I just need to find the x value right there. It's the same triangle, same angle really, same little angle here. So if you think about it, this was at pi over 3, so this is 2 pi, right? So if we go one full revolution and then take away pi over 3, I'm going to get theta is 2 pi minus pi over 3, which is 5 pi over 3. Okay? Because that's 3 times 3. That's 6 minus 1, right? So 5 pi over 3 is the second angle. Okay, so those are my two answers. Okay, so moving on to 8F, how to find the equation of a straight line using trigonometry. Okay. The rule that you need to know for this section is basically if I have a straight line, such as this one right here, okay, if I have a straight line and I know that it makes an angle with the x-axis, okay, with the positive x-axis. So basically I have to look at the angle that's on the positive side, okay. Then its gradient, so don't look at this side, don't look at it on this side, look at where the line crosses the positive x-axis and then look at that angle. Okay, that angle we can use to find the equation of a line. That angle we can use to find the slope of the line, I should say. Okay, so here's the rule. If a straight line makes an angle of theta with the positive x-axis, then its gradient is m equals tangent of theta. Okay, can you think why this would be true? How is it that the gradient m is equal to tangent of theta? Okay, I want you to think about that for a minute. Okay, well, if you think about what m means, what is m? M is the slope of a line, so m is really just rise over run, right? You know this from Algebra 1. If you have a line, okay, the rise is like the y step, and the run is over here. So this distance divided by this distance is the slope. That's the definition of a slope. Okay, and so if we created a triangle, and let's say this was y and this was x. Okay, if that was x and that was y, then the tangent of this angle is going to be, tangent of theta is y over x, which turns out to be rise over run, which is m. Okay, so that's why we can say that m is equal to the tangent of theta. Remember that the theta has to be from the line and the positive x-axis. Okay, so it's got to be on the, kind of think about it as the right side of the line. Okay, so let's try a problem here. It says find the equation of the line that's given. Okay, we know that theta here is pi over 6. Theta is pi over 6. So m must be the tangent of pi over 6. And what's the tangent of pi over 6? That's going to be the sine over sine of pi over 6 over the cosine of pi over 6, right? Okay, and so what's the sine of pi over 6? That's the sine of 30. So eventually I want you to memorize this. That's going to be 1/2 over the cosine of pi over 6, which is root 3 over 2. So that becomes 1 over root 3, okay, which is the same as root 3 over 3. So that's the slope. This is my slope. Okay, and then the y-intercept, if you think about that, that's going to be 1. Okay, so that's all I need, right? Y equals mx plus b. So y equals root 3 over 3 times x plus 1, because that's my y-intercept, 0, 1. And that would be my final answer. All right? Okay, well, this is your assignment. I'd like you to make sure that you do this during this long break, because you have until next week, Friday. So I'm going to cover these 3 sections. I've covered these 3 sections. So make sure you do all these problems. On Friday, when we come back from SEW, we will have a formative assessment. Okay? Please bring your completed homework to class. I'm going to record it in your notebook as an additional formative. So you must bring all your homework to class completed. Okay? The reason I'm doing this, guys, is because this section is so important. It's like the arithmetic that you need to know really well. Okay? If you don't know this really well, it's just going to make the rest of chapter 9 and 10 hard and difficult. Okay? So please go ahead and do this. Thank you for listening. All right, see you later.